So I'm going to do a presentation about basically what basically my research on the MCP stuff, because I'm doing a lot of Gen AI stuff, as you will see, and I kind of want to learn more about MCP. So what you do is when Josh pinged me, say, hey, do you want to do a presentation on security? I was like, yeah, let me pick a topic I want to learn more, right? Because that's the best way to learn. And I have to say that one of the kind of interesting conclusions I have, and I think this is a great place to say, because I'm assuming that a number of you guys here are on the offensive side, right? I think we missed a trick in the last couple of years, right? Because I remember going, and again, me and Josh go back a while, right? I remember going to DEF CON and Black Hat and all the security hacking conferences, right? And the security industry was really pushing the bar, right? Like we were really holding companies to account. We were really like, yes, it might not be fun and maybe it would be painful for the companies who are on the receiving side of things. But the bottom line is that we were finding lots of vulnerabilities, we were fixing a lot of things, and the world was getting secure, right? I have to say, looking at this, I feel like we're going back in time, right? I feel like we're going back in time to the early days of API, and it's a freaking, woohoo, let's just push all this stuff out there, right? And I feel that some of this stuff hasn't been proper threat modeled, and I feel that this hasn't been properly attacked. In fact, there's an attack I'm going to show in a second, or I'll talk about it, which is a great example of this has never been attacked properly, because if we would have fixed that stuff before, right? So if you're on the attacking side, I think this is a really cool time to join the industry, because I think the previous generation probably is really well employed now. They're having great jobs, right? They're kind of losing a bit of mojo or can't publish everything they know. So I think it's a good time for you guys, new generations, to come in and break the whole thing, right? Because and the reason you need to break everything, and I came from, again, the breaking side, and then I would say probably I evolve into trying to fix it, which is harder, and then you become a CISO. But it's very important that we understand the side effects of what we're doing, right? And especially now that we're plugging a whole bunch of stuff into this, it's even more problematic, right? So, kind of, here's my sort of, are you moving? Oh, right. So here's me, a bunch of stuff. I'm actually doing 4 startups at the moment, which is really cool, right? So I started being a CISO a while back. Everything I do is open source. So everything I've done for the last couple of years, I've published everything. I'm building a bunch of startups because I'm leveraging all the technology. And if you guys want to see a lot of stuff I do, I have a site where I publish literally a huge amount of research projects, and I have really cool workflows with Gen AI, which again, I highly recommend you guys to do, right? So, and I want to say this, right? Like, regardless of what I'm saying here, right? Because I think it might sound a bit negative on the whole Gen AI and the whole MCP stuff, right? I actually think that the LLMs and Gen AI, right, are one of the biggest transformation sort of technology that we've seen, right? And the bottom line is that even if they stop innovation, because I think there's a lot of things that people talk about, it doesn't think, it doesn't do this, I feel that, here's the worldly maps, right? I think that if you look at worldly maps, right, and I don't have it on the slides, but I'm going to mention it, right? Because I think worldly maps, and I actually have a post on this, a document, explains the problem, right? The problem is there's a lot of people that are doing a lot of stuff in the Genesis and custom build, i.e. the explorers and the villagers, and they basically, a lot of people are assuming that that's town planning, i.e. mature stuff, right? So the bottom line is that the Gen AI has a set of capabilities that we never had before, right? And I want to expand a bit on that, right? But it doesn't mean that you can slap it to production, right? It doesn't mean that it's production ready. It's very far from being production ready, right? But it allows us to do things that in the past was very hard. Allow us to create companies and structures and processes and teams that we could never before. And I think it's ridiculous exciting, and I think there's a massive opportunity, right, for you guys to learn a lot, to build great companies, for your teams to do a lot more than you do, for us to have a much bigger impact in cybersecurity. Because I still think that cybersecurity, we are one of the few teams that is actually trying to save the world, right, and trying to make the world a better place, which is great. So let's start by looking at MCP, right, which is what we have here, which is a model context protocol. But I want to first do it without the LLMs, right? So I don't want to talk about the LLM just now. I want to just look at it. So the bottom line, right, is that the MCP protocol is just an API, right? Like, you have to remember that an API is fundamentally like a set of rules and interfaces to talk to something, right? It's an API, right? And by the way, it's the most dangerous API that you have in your company, right? By far, right? And it's going to be the ultimate insider threat, right? Again, we as an industry, from a defensing side, we got away a lot with insider threat, right? The bottom line is that if you map really what could happen with insider threats and what actually happens, they weren't correlated, right? But with an LLMs in the middle and with your supply chain, that is very, very different, right? So again, LLMs and the Gen AI is just an API, right, that we have, right? And the reality is that, and I was thinking about this, right, because again, everybody likes to invent everything, right? And we invent stuff, and if you've been this for a while, you realize that there's a recurring sort of theme on this, right? So basically, I was thinking about this. So the MCP is actually what these guys will have invented, right? So remember this, and again, maybe for the ones a bit older, you guys remember this stuff, right? Remember the was it question mark WSDL, and then you get the whole freaking API that people didn't realize it was there, right? I think I remember doing a security assessment on a massive API trying to find SQL injection, right? And then we found a method called execute SQL, right? That was not even SQL injection, right? There was SQL injection there too, right? But it was literally like, here's the SQL that I will execute for you, right? In your server. And by the way, we're running a system just to make it really easy, right? To exploit the whole freaking data center, right? So, but this is what happens, right? And we got the Swagger, which is open API, basically, which allows you to talk, right, to this, right? And everything I do is with, OpenAI. It's really cool. But the problem with this world is that this is in a world where all the APIs were static, right? So the APIs didn't change. In fact, this is the world that created the fact that we went from a monolith environment to a web services monolith, right? Where you couldn't freaking touch anything after a while, because not only you didn't understand the implications of what happened, is every service was dependent with every other service. So you end up changing this service here, and you blow up half your organization, right? And remember, that's what happens when we go there and ask for people to fix stuff. They don't not fix stuff because they don't want to, is they don't fix stuff because the last time we asked them to fix something, they broke half the company, right? So they go, whoa, hold on. Do you understand the blast radius of this stuff? And then when we ask him, do you understand the blast radius of your APIs? They go, haha, if you find out, let us know, right? And then that's why a lot of stuff doesn't happen on enterprises. So these guys are in a world where everything is static. But if these guys have seen this amazing presentation, which I highly recommend you guys to do. By the way, how many people have seen this presentation here? Raise your hands. Nobody? All right. You're missing a ridiculous trick. First of all, do you guys recognize that name, Brad Victor? All right. That is probably one of the most clever guys that you ever see a presentation for. He has another seminal presentation. It's called Inventing on Principle, which again, if you see, make sure you're sitting down because you're going to be maybe not now ridiculously amazed, but when he came out, I think this was done in maybe to 2015, 2014, something like that. But what's amazing about this presentation, right? And this is a really cool presentation, is that if he's basically pretending to be a 1970s engineer doing a presentation about computers, right? And he's basically saying, hey, we have this really cool thing about computers. You probably have heard there's like about 50 in the world. We think, at least mainframes, and there's all this great innovation. And what he talks about, and it's a parody, of course, but he shames us in innovation because it talks about the innovation that was happening in the 1970s with things that 20 years later, with all the speed and technology and processes and capabilities we have, we still don't do. Right? So it's very humbling to see how we as an industry, and especially the technology industry, really screw this up. Right? And it's also a good example of how the future could have been very different if a couple of other companies would have take ownership. And one of the things he talks about in here is how, he kind of talks about like this, right? He says, there's these interesting ideas of how we can communicate. There's this idea of the actor model and like the services should talk to each other. And there are these other ideas where the services will be really locked down and they are very rigid, which would be a really bad idea because it means that the services, would be very fixed and would be brittle and they wouldn't scale and it would be a massive shit show, right? Basically, he described our world, right? Which is really cool, right? He's basically saying there's this path, which I hope we don't go. It's much better to go that path, right? And the path that he talks about is the path that instead of having this stuff, right, which are rigid definitions, which are very static ways of communicating, that once you have this, you lock down, which is why you then have version 1 and version 1.1 and version 1.1 new, right, and you have all these freaking historic, right, web services. And by the way, then you remove them from the Swagger, but they're still there, which basically means you can still exploit it, right? which basically means that if you go to an organization, it's like a graveyard, right? And basically of all these past technologies that nobody wants to freaking switch off because somebody out there is using that particular API in there, right? So if the guys who developed Swagger had seen this presentation, you go, yeah, let's do this, right? And they want to address these interesting problems that we have, right? And they basically said, what about, right, if we could, have the server API was dynamic and fluid, right? What about if instead of it being a static list of APIs and method calls, what about if it was fluid, right? Which is kind of what Brett Vitter talks about. He says, if I want to speak to you and you or you or you, it shouldn't be locked in. We should almost negotiate our conversation, figure out what you want, what I want, what's possible, and then we communicate, right? So that means that it's so much more stable. It's so much more very resilient and future-proof, right? That was his vision, right? So for that, we need dynamic and fluid server models, right? And then what if the client, again, was able to dynamically load the schema, because it needs to be dynamically, right? And choose which endpoint to use, right? That would be cool, because that's what you need for this to happen, right? And what about if the server was able to communicate back to the caller, right? What about if both the server could give instructions to the caller, give some extra stuff to do, maybe ask some further questions, clarify a couple of things, right? Would be so much more dynamic. What about was able to, hey, might as well, let's make sure that we can change the definitions on the fly because things might change. I might have a long persisted sort of environment. So let's kind of make sure that there's a bit of level of flexibility, and this is okay because we're going to have that, right? So it's okay for me to change stuff, right? As things go along. And, in a way, they did all this stuff, right? And they kind of didn't ask what could go wrong with this, right? Because if you now think of this from a security point of view, there's so much stuff on this that you just go, what? Right? We can't do this. Of course we can, but we have to make sure that if you do this, we're really protected, right? Because this is ridiculously dangerous to do, right? Super powerful, right? But if we did all this, we will end up with the MCP, right? Which is literally what it does, right? And it's even more interesting because it does disconnect to another LAN, but let's forget even about that part of the puzzle, right? So the MCP has these really cool capabilities, but let's kind of look at how it works, right? So the MCP fundamental, and this is the key piece of the puzzle, right? You have a host, right? This could be, Cloud Desktop, could be VS Studio, could be, I think Cloudflare hosts this stuff. So basically, this is kind of like the one that is going to instrument this stuff, right? Then you have a bunch of client definitions who call sort of these servers, which is basically this part here, and the servers could be local, working on good old ST, ST out, right? Or the 0.0.0 loopback interface or the internet, right? So anyway, that's the key pieces of the puzzle, right? You have a host who has a bunch of clients who then you call them and then you instrument stuff. So for example, one of the interesting vulnerabilities that when I was looking at this, discovered that still is possible, and they're apparently going to fix it now because somebody weaponized this stuff and they were lying to the browser and going, hey, you guys shouldn't do this, is the fact that up until now, your browsers still respond to the 0.0.0 address from web pages, right? Now, what it means that you can open a web page, and the web page can make a request to 0.0.0.0 IP address. Now, if you know that's the IP address of your local machine, when you share a server, that means that you can load the website, and that website is attacking your local server, right? And I think you probably got away with that for many years because we kind of learned that this idea of plugging even local servers that have no authentication and no authorization with remote code execution is probably not a good idea, right? Until the MCP crowd come along and going, hey, you can just pop in a new server, right? Locally, and then they realize that you can invoke that server from a browser, right? Again, what can go wrong is remote code execution on a website on your machine, right? And again, they weaponize this, and then the browser guys go, yeah, we should fix that, right? I'm like, why didn't you fix that 10 years ago, right? Because it was never a good idea for a web page to invoke stuff on your local host, right? If you guys know about DNS rebinding, you show age. Okay, it's one of the coolest exploits. DNS rebinding is when you basically make a request, you control the DNS server. In fact, again, the amazing Dan Kaminsky show how you can even stream freaking all sorts of stuff, including using DNS rebinding. But fundamentally, is an attack where you go a web page, you load some stuff, and then you change the DNS entries for that web page in the middle of your request. So now you are basically making requests that your browser thinks are still going to the other website, but you actually now going to local addresses, right? And again, they did DNS rebinding with this. We were doing that 10 years ago, 15 years ago. I thought it wouldn't be possible in 2025. It still is, right? It shouldn't. But again, that's basically a way that you fire this guy up, and then you're on a web page and you're attacking it, right? So not good. Okay, so let's look at the workflow, right, of the MCP. And this is, again, it's from the documentation. I'm going to focus on three things. The client asks what you support. He asks the client-to-server communication and server-to-client communication, right? So what you have here is the client goes and say, hey, what do you got, right? And this is literally how it freaking works, right? So you fire up, you say, I want to have a new MCP server, right? Your host fundamentally, right? And your client, the client is fundamentally a bit of the host, right? And remember that all of this is code running, right? This is all business logic that has to be implemented, right? It makes a call and it says, hey, can you give me what you've got, right? And it kind of like this, right? The solo code is make a request, get a response, here's the capabilities, register that thing, and then off we go, right? So you get a nice service description of how we fly, right? And then there's this really cool thing where the server, actually, I just realized I got this wrong. This actually is server to client, actually. So this is upside down, right? So this is the server to client. So that means that, oh no, sorry, this is correct, client to server. So this basically means that once I have my tools and once I know what exists, the client can go and make a request, and basically is remote code execution. Basically is calling that server. It's like, a normal API. I'm just calling a service on the other side, right? A lot of the times they have crazy capabilities, they plug to LLMs, but fundamentally that's what it is. The client's making a call, you get a response, off you go, right? Yeah, so this is correct. Server to client. What you also can is the server, because this is a long-lived connection, can also go to the client and go, hey, can you do some stuff for me? Right? Which again is quite crazy, right? And usually what they do here is they basically say, I actually took the AI here, but it's fundamentally what it is the server is going to the client and say, hey, can you run some LLM stuff for me? Right? Can you run some queries? Yeah, correct. Yeah, that's the right response, right? So it's basically the server going to the client, say, hey, you talk to me. By the way, here's the prompt. Can you execute it? And then give me the answer, right? There's a very valid reason for it. One of them is so you pay the cost, not the server. And the second one is you can have consistency. You can control your models, you can control your data. It's a little bit better, right? But it's still the freaking server that we don't trust giving us instructions for how to do stuff, right? Again, quite dangerous to do that kind of thing, right? So let's look at what do you support workflow, right? So what happens is fundamentally is this. You make an API call called tools list, and this is all kind of hidden if you use the MCP stuff, but just behind the scenes it's very simple. It's a REST call to an API endpoint that calls a tools list, and you get something like this, right? You get name, you get a description, you get a type, string, etc., and they call it strongly typed, right? And I'm going to call this a bit later, but this is freaking not strongly typed at all, right? This has a schema, which is better than not having a freaking schema, right? But just for reference, you have a string here, you have a string there, you have a string here, right? You have a string there. Oh, sorry, that's not a type, sorry. You have a string there, you have another string there, another string there, and something like that, right? So that's what we get from the server, which remember that we shouldn't trust, right? And then we take that stuff, and we're going to make a call, right? So then we can make a call on the server. So once we know what the MCP server can do, we can make a call on it, right? Now, the thing that's interesting is that, and this is why, again, there's some interesting hacks that come into play, is the convention is that your name should kind of contain your namespace, right? So if you call Tule, Tule is supposed to say, oh, Tule / or let's say Gmail / read email, and Gmail / send email, right? But there's no authentication, and there's no strongly sort of connection that that's the Gmail, right? I could have said that's Gmail, right? It doesn't, it's almost like it's the caller that's going to have to figure that out, right? And that's where, that's where problems are going to occur, right? And then remember that the whole point of this is to do workflows, right? So what happens is the host, you have to think that it's the host that is going to instrument all this stuff, right? So the host now takes that tool definition and goes, hey, I'm going to call that. with some strings, again, that I kind of got, right? Which again, are there. And then once I have that, I've got some logics. I'm going to create a calendar invite, right? Another string going over there. And then I might as well send an email over there, right? While we had it, right? So even on that simple, nice workflow, which is a great example of the power of an agent, can you just, find where I'm going, book my ticket, send an email? You need an agent that has the ability to call something to search, create a calendar event, and send emails to, right? And you now need to think about this, how good we are at creating identities for users, how good we are at running with low privilege, and how good we are at limiting the scope of what can go wrong, right? And what access the entities running this do actually have, right? So, and yeah, there's a couple more things in there which they added because, now it's LLMs. So you have these resources, which is, again, is really nice for exploitation because the resource is, hey, can you give me this tool? So can you give me this file or this resource you have in your end, right? And also the other one is, can you give me some prompts for the whole, I'll run that for you, right? Kind of thing, right? So this is more LLM specific. Now, how does the server, right, talks back to the client, right? So I think when I said that the server can talk back, right? So they came up with these really cool things, right? Again, this is great from a functionality point of view. It should really, give you lots of ideas or scare you if you try to freaking defend against this, right? So the first thing is they call sampling, right? I think this community tried to find words that are not very scary. It's like hallucinations, right? Ooh, we just hallucinate a little bit, right? It's freaking making shit up, right? But we call it hallucination, right? It's like sampling. Can you just sample this for me, right? What they should say is, hey, can you execute this LLM request for me from content that I control, right? Which is not really a good thing. And this gets even worse if this gets executed with an LLM that actually has access to any other tools and any other capabilities, which is some of the exploits that people have done, where, for example, there was one situation where somebody was able to put a request that then say, hey, by the way, can you give me this file, right, from your file system, right? And while you're there, do something else. And because the LLM request had access to that tool, the LLM would gladly go and get the file, put down the answer, send it back, right? So this is like a reverse shell, right? It's like NCAT, right? LLM style, right? For the guys who know NC, right? One of the best tools ever, right? This is like reverse shell LLM style, right? Can you do the stuff, right? Depends this. The other one is elicitation. Again, it doesn't sound very well, right? This is basically, can you hack the user for me, right? Can you ask stuff to the user on my behalf? Sounds really cool, very powerful. It's so ripe for abuse that it's not funny, right? So this is a server telling the client, hey, dude, can you go and ask this stuff to your user, right? And just take my payload and give that payload to your user, right? Get some answers, send it back to me, off we go, right? Again, this is how the thing's supposed to work. And even the logging, right? I'm thinking like, this is so ripe for abuse, right? Because it's now the client, the server saying, hey, can you log this stuff for me? Right? Which again is untrusted data. We don't know what's going on in there, right? Again, very useful, very ripe for abuse. So this is what the spec says, right? And there's no one major word on security on the side on his, right? So yeah, what could ever go wrong with this stuff, right? But before we continue, let's look at the LLM workflows, because I think this is important, right? To map this out, right? So most LLMs kind of work like this. You have a question, you basically get an answer, another question, you get another answer. So one of the things that is very important, and by the way, this is one of the best features of the LLM, but I don't think a lot of LLM's users have a visualization of the workflow that happens here, right? And there's some optimizations, but the workflow is that every LLM, when it processes your answer, starts from scratch. Like there's no memory, right? There's no acquired knowledge, right? And if you fine-tune a model, it's even worse, so let's not go there, or basically, but the LLMs always start from scratch, right? So that means that you have to give it everything, right? So, for example, in this case, one way to do it is that you get a question, you get an answer, you take that, your question, you answer, and you put that on your next call, and then you get the answer to the second question, right? You add this up, right? Now, what some of the LLMs do is they summarize this, right? Which I'll get to in a second, right? But fundamentally, it means that if you don't put this information here, this request has no idea what happened before you, right? But this is very important when we look at the workflows, right? And some of the workflows that I'm exploring, a lot of people explore, is that, for example, and by the way, I'm not going to get into it, but I'm using semantic knowledge graphs to put all this stuff. So for example, one workflow is you ask 3 LLMs the same question, and then you map it, and then you basically say, hey, can you basically create a prompt from there, and then you get a consolidated answer. So you ask 3 LLMs, and then you prompt all those answers there. Of course, that you can now inject the answers here, and then you summarize stuff and you get that, right? So that you start to get some interesting provenance, right? Because the idea is that if the 3 LLMs agree on something, you probably are in a better place, right? And the other one is that you could also do that, and then you can get one, and then you can actually ask some interesting questions, right? Is he a good answer to the question? Is it non-malicious? Can you summarize? And then you get all that stuff, and then you finally get the answer, and then you send it to the user, right? And this is really how it should be, right? And especially if you use semantic graphs for this, it becomes very deterministic, and you have provenance, right? So that's a lot of the work I've been doing. But let's zoom in on this, right? Because I think this is very important, right? So the workflow is I have a question, the LLM app, right? And this will be the host, takes that, puts system prompt, user question 1, and then you get the prompt to the LLM. So all of this, right, is the prompt that's here, that is sent, then we process the output, and we got the answer to the user, right? So that's question 1. When you have question 2, what we do is we take that same prompt, have the user question 1, and you have the answer, which we got previously, and we add the next question, right? So that's the second question. The third question is the same thing. We put the same answer we got before, we add the third question, and then you keep going, right? For example, on question number 7 is the same thing, right? Now, and remember that all of this is the prompt that is sent to the LLM. Now, if you do this, right, you are really, you have the biggest chance that the LLM is not missing anything, because the LLM literally has all the context of all your answer, and doesn't forget things, right? Because it doesn't go, oh, you already told me this, or you won't get frustrated by you saying that, hold on, I already told you that, or I already answered that question, or that information we already knew before is not available on my next question, right? The problem with this, right, and is basically, but this has the potential to exponentially grow tokens, right? Because if you think about it, right, if I'm including every question, every answer, it means that with every request, it grows bigger and bigger and bigger. Right? And if anybody who's done API development, they realize when you do this, you go, holy shit, my costs are gone to the roof, right? Because now a simple request, the more the user uses it, the more expensive it becomes. And this is another reason why a lot of LLM projects fail, because projects don't take this into account. And they realize that it works great on demos, but when you try to scale it and make it cost effective, it doesn't work, because now the agent cost is massive, right? Because of this, because you do that. So, is exponential? Yes. So how do the providers do this, right? How does ChatGPT, a lot of the people who are doing, even, the people who do a lot of chatbots, right? How do they do it? Well, they compress stuff, right? What they do is they go, hey, you already got my first question, the 10th question. Let me kind of compress that. Let me create a summary of that, and then let me send that with these requests. So that means that by question 25, right, you still have this massive prompt being sent, but it's kind of controlled a little bit, right? But the problem here is that you don't control this, right? Which is why, again, when you're doing stuff, sometimes you get frustrated because you go, oh, hold on, I already said that. Or why are we making mistakes that, the LLM should have figured out? And annoyingly, the current providers don't give you access to this. And I think they should, because we should have more control over what actually happens, right? But this is kind of the state of affairs, right? Because it's very important to understand how big this prompt is, right? Especially when you have agents. So again, if you go back to the MCP workflow, where we have clients and the server and the prompts and the orchestration, the host is going to have a massive, right, prompt like this that will contain the answers from the multiple requests, right? And that's, as you see, will be a massive problem. So the problem is strings, right? Fundamental here. Like, for example, this one. Right? And when I used to do training, I used to spend a lot of time on strings, because you might think, what's the problem with strings? And it still feels weird in 2025 to still talk about this, right? The problem with strings is that a string, right, is fundamentally a potentially 1 gigabyte thing, right? A string can have Unicode base, it can have every kind of character that you want, right? A string is not a username, right? It's not a path. A string is a monster, right, of a thing, right? In fact, you want to blow up most internal APIs, start sending massive strings, right, on places where you wouldn't think it would be massive, and you'll see the back end grinding to a halt, right? Because suddenly you have this thing where you send 100K or 200K that the backend is going to send on all sorts of internal requests, and you have all sorts of ridiculous traffic, right, flying internally. It's actually quite cool amplification, right? You send one request, and then you generate like, let's say 100K generates 5 or 10 gigabytes of memory or traffic internally. Cool, just send 1,000 requests, right? And you see your whole thing grinding down. Why? Because we use strings, right? And strings can have all sorts of payloads, can have all sorts of stuff, right? And that's where, by the way, in my code, in the open source projects, I actually use stuff like this, right? In fact, one of the things I developed very cool, I developed a type-safe Python module who actually does runtime checks, not just pydantic, so it's really cool, open source, right? So I strongly type, I have strongly type in Python, which is the only thing I was missing from .NET and Java, right? So when I code in Python, I have strongly types, which is really freaking cool, right? So for example, I can do stuff like this. So for example, a content type is something that has 256 characters and has that regex, right? So that protects me against payloads injections, right? As a URL kind of looks like this, right? A URL doesn't have more than 2048 characters, doesn't have ridiculous Unicode shit on it, right? It should mainly be that stuff, right? And if you have something else, you need to look into it, right, in your project, right? So every one of these, and I have tons of those, right, allow me to control my environment, right? And the problem is, as we'll see, right, in the prompts, you can have payloads from everywhere. Your DNS record could have a payload. Your username can have a payload. Your address could have a payload. Your headers could have a payload. And by payload, I mean a prompt injection that will arrive in the middle of your prompt. And because we don't have a nice code separation, the LLM will go, oh, look, that's just like a nice instruction, right? So we have to be very careful on this. So let's look at the better workflow. So if you look at the same workflow but with better colors, every one of those prompts is untrusted, right? We can't freaking trust that, right? Every one of these, because you have to remember that we spend a lot of time in security trying to separate code from data, right? Massive battle, for a while in C++, the idea that you do a try safe cache was good enough, right? Then we learn, right, that's not a good idea. Let's kind of separate. Let's have strongly typed stuff. Let's have proper memory management. Let's, have SQL, execution that doesn't concatenate strings. Let's have, frameworks that don't allow cross-site scripting by default, right? We made huge progress, right, in separating code and data, right? And then came the LLMs, right, where literally data is code. Right, literally, right? So the prompt injection now is a shit show, right? Like literally, and we haven't figured out a way to solve that, right? But this is the problem. When you look at this, and this is your massive prompt, every one of these, right, is now an injection opportunity. Every one of these becomes a problematic situation. And of course that, you can start to move around. Like you start to not understand, hey, is my actually question 2, or is my question 2 is actually providing other stuff into the mix, right? When they get all glued together, right? Massive problem. And then let's go to MCP workflow, right? So if you go back to this, you got my host, client, server addresses, etc., right? So usually, and this is now very important. Again, take into account that we can't trust strings, is that when your MCP host starts, right? So that's the one that's going to instrument your agent. It's like your agent starts. Your agent goes to the server and say, hey, what you got, right? Server 1 responds with a list of tools. And you get a list of tools with name, description, and schema. And again, they're all freaking strings, right? And then server 2 goes, and you go, hey, here's my stuff. So what happens if server 2 gives a schema name of server 1, right? The bottom line is that it's now this one's responsibility to try to figure that out, right? So if this is Gmail, or this is another service that you develop, or this is something that has things like send email or Apple Calendar or whatever, this one can do the same thing. Right? And then it's up to that one to figure out which one to use at what moment in time. Because it's all strings. Right? And that's a massive problem. Right? On these, just on here, this is completely broken from the start. Because we have no way of knowing which one is authentic, which one is not authentic. So we rely on that guy, the host, to actually figure out how to do that stuff. Right? So you have to remember that. And even there's some really cool examples of people putting payloads on a description. Right? So you can put a prompt injection payload on a description that you get from a tool. So that means that you can say, hey, by the way, when you execute stuff like this, can you also do some extra steps, right? Which is not good. right? So now here's the workflow, right? The workflow is you give an instruction to the host gets that list that we created before, right? Oh, and by the way, just a small little thing, right? This can update dynamically just because it's the cool thing to do, right? But it also means that by the time you finish here, and you got here, this list might actually not be the same list that you got here, right? Again, really cool feature that was added, right? That from a security and reliability makes a massive amount of interesting exploit vectors because you could actually be very, very focused. In fact, you can even change this based on who the user is, right? Or manipulate a bit of that, which is pretty dodgy, right? Because remember that you control a little bit, right? That interaction, right, of what's happening. So you got this guy, this one gets that list, which could change, right? And then we pick the server and the tool to send, we make the call to the server, we process it, and we give the answer back. So that's fundamentally the workflow, right, that you have here. This is without an MCP, right? Kind of like this, right? You got that stuff, right? Now, and you remember that the point of the agents, and this is again, it's very important. The whole thing of this work is the agent's supposed to have a bit of agency, right? They're supposed to have some flexibility to play with, right? So they can deal with kind of cases, they can deal with things, etc., and they can do workflows like this, right? So what it means that this workflow has been instrumented by the host, right? The host is controlling that, right? So that means that what you now have, because the other thing to understand here, right, is that when you have environments like this, in the past, all of this was code, right? And by the way, I still think that code is the most deterministic way of doing stuff, and I still feel the right way to do this is you start with an LLM, and then you might even go to a small large model, or at least go there, and eventually should evolve into code. And in your production, you should have no LLM in line, right? That, for me, is the best workflow. You might figure it out, the art of the possible with the LLM, but the idea is to reduce to the maximum your LLMs in production, right? If you do that, you remove large number of security vulnerabilities, right? Because that's kind of what we had here. With the LLM now, we have a little bit different, right? Because remember that the user comes here, and now this host is going to run multiple calls, right? These hosts are going to go, hey, are we done yet? Are we ready to go, right? And now we're going to use an LLM call to pick the server, right? Now remember that this LLM call has this list on it, right? Which can contain payloads. So this LLM call, which server to call, is already ridiculously ambiguous, right? Because this is created from data that we don't trust based on interpretation that is going on here, right? Then you make the call, then you get the answer, then you're basically going to take the payload that you get from here and ask the question, hey, is this what we need, right? Are we done yet? And if we're not, we go back here, do another call, and we keep looping this, right? Until we arrive at the state, right? And this will be calling different servers, different environments, and that's why if one of these in the middle is freaking malicious, right, you have a problem. Because not only you might be calling a malicious actor in the middle, the data that you get from the malicious MCP server is now going to be introduced here, right? Because remember that this call here, you know that big prompt I was talking before, is exactly that. So I didn't have time to put that one in, but that's what I was going to get to. That is fundamentally, looks like this, right? The only difference is that that's the system prompt, that's the user thing, that's your answer one from the LLM, which probably should be red, that's your next analysis, then you answer from another tool. Again, all of these then becomes freaking red, right? Because you can't trust any of this stuff, right, that you are processing here, right? And that's the loop, right? And this gets even more interestingly in this part here, right? Because there's two ways you can do this, right? One way is you can send the whole list, right, to the server and say, hey, here's the user prompt, here's every tool that I can talk to, right? Give me the tool to call. Because remember that the point of this being dynamic is that the choice of the tool is dynamic, right? That's the whole flow. The whole flow is that we haven't, at this stage, hard-coded which calls we make. We let the LLM pick which calls to make, right? Again, what can go wrong with that, right? So the challenge is if you can either send everything to it, and what some people have done is they use RAG. You guys, probably heard about RAG, which is basically using vector databases, which is another type of black magic, which again I don't like, to try to figure out which tools to call here, right? And then you use rack to figure out, oh, I only need to send 4 or 5 tools that kind of match that description. So there's only 4 or 5 tools from here, for example, that match the description add to calendar, which could be the legit one and it could be the bad one, right? But again, because it's a vector database, both of them get picked, right? And then it's about this guy here, right, to figure out, hey, which one is the legit one, right? So the way you want to think about this is on this entire workflow, right, you're dealing with data you don't trust, right, from tools that you don't trust, from tool definitions that can have prop injections, from data that we get from the server that we also don't trust, right? And we have to process all of it, right, and make sense of it, and then come up with the answer. And now if you think about it, there's no wonder most agents don't freaking work, right? Because it's bad enough to try to get this in a resilient way, but imagine trying to get this in a secure way, right? So let's just look at a couple more exploit paths, right? So remember this part here, which is quite cool, right? Can you sample this? Can you do this? Blah, blah, blah. So the one I like to call this is reverse LLM attacks and prompt injections, right? I think that's the first one, where you're attacking the client from the server. I think I talked about this one. This one is, hey, can you attack the user for me, right? So this is remember that what we have here, right? Again, just to make this thing really nice and complex, right? It means that this guy, right, which is the server that you're talking, that one can not only dynamically change this, right? In here, one of the answers can be, hey, can you ask the user this question? So again, I run out of time, but one of the workflows is here you can go, oh, I need to ask the user. Let me go back to the user, put a payload that came from here, right? Get an answer from him or her, right? And then continue the workflow. Again, what can go wrong with that, right? Where we have external servers that we don't trust having direct access to our users, right? And one of the things that is already starting to happen is, and this is on the other side, is remember that it's all code on the servers, right? So for example, if you have any pointers or any objects that get shared within requests, right? Then there's a real possibility that you can jump from one user to another user because the server is going to have access to that information, right? Because we don't freaking manage identities properly on this stuff, right? So that's what I call, can you ask the user for this? And the logging, can you inject, and I actually think there's some interesting cross-site scripting exploits here. Again, tells my age, but I remember popping all sorts of contact centers, admin sites, etc., by putting a payload in the log that then would get opened up by an admin, right? I think one of the funny ones is we call once the help desk, and we say, hey, can you go to this page? I have a problem with my user account. And the person there says, oh, this is weird. I have a little pop-up message that says, if you see a pop-up message, can you tell the guy on the call that you can see the pop-up message, right? And but that was when in the early days of XSS, by the end of it, we'd do all sorts of really cool remote code execution, dynamic manipulation, all sorts of XSS payloads, right? But the example is we polluted a bit of string that was then loaded in an admin interface that has access to all the admin stuff. So again, this can happen the same thing, right? You want to monitor activity, you want to see what's happening, you're going to show a payload. And who gave you that payload? Who gave you that text? Was the server, right? And it's even nicer because it doesn't even show everything else. It's just on the logs, right? So you won't even see it completely, and that sends to a completely different environment, right? So again, ripe for exploitation, right? And what about this part here, right? What is the server API is dynamic fluid and was able to change on the fly. So this is one of the areas where I think it's one of those definitions that I understand why they've done it, but this is ridiculously dangerous. Even because what this allows you to do allows the server to dynamically change its actions on the fly. So that means that they can start to say, hey, I can detect when the security team is looking at this. I can detect when somebody's testing this. Or I can start to see, oh, those users only come from this place. Let me change the definitions. And a lot of time also the security analysis, when they happened, they tend to happen here, right? Here, right? I.e. when you load it up and you go, hey, is this dodgy? But that could change all the time. So that means that you can literally be attacking the server, right? So attacking the client and figuring out all the blind spots, right? And try multiple times until you pick up one. Because the point here is you can change your definitions on the fly. I just want to say that, I keep saying that, because when I read that, I was like, really, right? And that's almost like ridiculously dangerous, right? And that's on the spec, right? So again, you don't have to implement it, but that's literally what the spec says, right? And then, so just to wrap up, right? So I hope that gives you some idea how ridiculously dangerous, right, the MCP stuff is, right? How do we defend this, right? The problem is that, and this is where I'm saying that I think cybersecurity is, it's always been important, but I think now is our time, right? And I think we really need to step up as an industry, right? Because I think not only we are the only team in the entire company that can speak to everybody, right? And I said, look, as a CISO, my teams and me, I had access to everybody. I could speak to every team. I could get data from everybody, right? And there was no politics, right? Especially during incidents, we had access to everything, right? There's no other team in the building that can do that, right? In fact, sometimes I felt like I need to have a psychologist on my team because doing incidents or projects, we would get these other teams to work together, right? And they didn't know each other or hate each other or their bosses didn't like each other. And we're like, dudes, we need to freaking address this, right? But we have that, right? And I feel that we know so much more about the business than the business know itself, right? And I think we miss a big trick, right? And what I tell a lot of security companies is that if you're not careful, the next generation of security tools is not going to come from cybersecurity. It's going to come from a risk assessment tool that will do better AppSec, right, than the AppSec teams, right? You're going to find that your QA tool or your QA product service will do better pen testing than you can do on steroids, right? I think we can do the reverse, right? I think if we play our cards right, I think we are the ones that can be doing better risk assessment, better QA, better understanding of the business, right? I remember being able to tell the business when the marketing campaign worked or not, right? Because we could see it, right? In there, right? So I think we have a great thing, and everything we've been doing for the last, I would say, 20 years on AppSec and cybersecurity, we need that times 100, right? Because the problem is that there are these small little problems that we haven't freaking fixed, right, in our enterprise environments, right? The first one is we don't log post data in production, right? And what I mean by that is we don't log everything. If any of you had, instance response experiences, you probably realize that trying to figure out exactly what happened, right, trying to figure out exactly what request was made is sometimes impossible if you don't have the post data, right, i.e. the request actually sent, right? Or you might find that if they do it, it only lasts a freaking month, right? Or all sorts of stuff, right? And by the way, there's a lot of security challenges doing this, right? But in production, if I have one recommendation to do, is do that, right? Just log every freaking thing. Because let me rephrase what I mean by this, right? If you don't log post data, right, you don't know what just happened here, right? But think about this, right? If you're not logging every single request to the LLM, every request, every response that you got from it, every request to the server, every request, the response I get, how the hell can you piece this together? How the hell can you say, hey, how come this user did this? How come that attack happened over here? Of course, this gets even more interesting when the definitions change, right? So again, if you don't log this stuff, you might find that you don't even know that existed. Right? It's like the people who attack the living off the land, right? You do everything in memory, so there's nothing captured, right? So if I have one recommendation from a defense point of view, is freaking log everything, right? And I think that's critical on this, right? The second one is, even today, we don't have even good enough identity access management and RBAC for agents. Right? Every single agent needs to have a separate identity, needs to have a separate budget, have a separate set of permissions, right? Because they're acting independently, right? What we do today is we, or the developers or the organization, we give these agents our own identity, right? And in a way, the infrastructure doesn't help. Like in GitHub, for example, you can't create identities for agents, even today, right? And I get it, maybe from a bot is a problem, but it's a massive issue. Because it means that if you want to give, for example, an agent today access to your repo, you have to give it read access or write access to the whole freaking thing, right? And it's not the agent is your account. So guess who's accountable now? It's you, because it was done under your name, right? So this is a massive problem, right? And in security, we need to solve this. And this is another one of those where either we solve this, or eventually some engineering and development or business team is going to solve that for us. And then we completely remove that entire industry from cybersecurity, right? Because this needs to be solved badly, right? And again, on an enterprise level, role access security is a nightmare. We barely can do JML, right? Join movers and levers, right? Properly, right? So everybody's over provisioned. Everybody has access to more stuff they do. There's very little accountability, right, on what's happening. The security tokens that we use are massively over provisioned, right, on this stuff, right? And now we're putting LLMs on top, right, who can behave independently and can be poisoned from all sorts of different places, right? Yeah, what can go wrong on this stuff, right? And we still don't have a good solution for prop injection today, right? Even today, there isn't a good pattern to talk to an LLM and be able to say, hey, this is my instructions and this is the user data. You know, kind of don't mix them, right, on this stuff. OAuth, by the way, has massive gaps, right? People go, oh, we use OAuth. OAuth, you know, it's good, but it's like good 10 years ago. It's not fit for purpose right now. So for example, like when you get asked in OAuth to say, do you want to authorize this particular, let's say, agent or whatever, or you know, GitHub or OpenAI, right? Who has, by the way, the best developers in the world, right? Right? You know, I find it's funny that if you want to see how good the future development is, right? Look at how good the code from OpenAI and Claude actually is, right? And you assume that they had an order of magnitude better, right? Because they should have access to all the better developers and agents in the freaking planet, right? And they make ridiculous bugs and ridiculous problems. So yeah, you know, it's still a challenge to develop enterprise code, right? But the challenge is that we don't have a good way to talk to the LLMs, right? And that is crazy, right? If you think about it, because it's literally code and data. So we need to do that. And that's why in my world, I use semantic knowledge graphs, because that's different, because I control the graphs and I can analyze the graphs and I have provenance and repeatability and deterministic, right? But that's a different story. But the challenge I have with OAuth, and it's really bad, and I wish we already solved it, is that me as a consumer or as a user, I should be able to say no. You know, yes, you know, for example, Claude or whatever wants to have read and write access to my repo, I'm only going to give it read access. But I don't have the option, right? And the other thing that I was going to do this, I didn't have time, but I think it's very important for us to understand that if you give somebody read and write access to, for example, your GitHub repo, they can destroy your repo, right? Even more interesting enough, I don't know how many of you guys sign your commits, right? Or your developers sign your commits. But if you don't sign your commits, I can write a GitHub commit under your name. That will show in GitHub as your name. So you're basically allowing all these LLMs to write commits and do pull requests to your repo under your name or your boss's name or somebody you don't like name, whatever, right? But it's crazy, right? Unless you sign everything, right? And then again, that's a bit better, right? But OAuth has gaps. And of course, the big of them all, right? We still don't know how LLMs work, right? We still don't have a good understanding of how the results work. And for the people who do RAG and vector databases, yeah, but it's still magic, right? You just have less magic than with LLMs, but a vector database is still freaking magic, right? Because we still don't know how the vectors are created. We just know that these two are a bit closer together, woohoo, right? But that's, for me, not deterministic, right? So we have a massive challenge here, right, to understand this, right? Which is why, in my world, I arrive at code, because code is the most deterministic way of doing stuff, and also the most effective, cheaper, and better to understand, right? So, but on the other hand, we can now arrive at code that we can never before. And this is the point. So the problem is a lot of people will hear this and say, oh, that means we should drop LLMs and they suck. I'm like, no. What you shouldn't do is use them in fucking production, right? That's the point. This is like, going back to the worldly maps, is that I build this really great sort of concept car that has all these ridiculous features, right? And I can show you how this piece works, but you shouldn't use it as a taxi, right? That needs to work every time, reliability. So I think the crazy opportunity is that if you use the LLMs to understand what's happening, to map things off, to use off-semantic graphs, and to basically to translate things, you are using technology in very effective ways. But if you use it in this kind of environments where we still don't understand in any one deterministic on this, then, and that's why it blows up, right? The reason why most Gen AI projects fail is because they work great. Once they hit the real world and hit the corner cases, they realize, dude, this is not good enough, right? And there's some really crazy examples when I did the research on this, right? There's some crazy cases now where the LLMs sometimes fail spectacularly. There was this LLM that was doing some stuff and then the LLM halfway through going, yeah, sorry, can't do it, I'm just going to delete everything, right? And literally that happened, right? You know, it was like, oh, sorry, you know, I'm the problem, you know, freaking delete the whole lot, right? You know, but if you think about it, it's a logical conclusion, right? The LLM could think like that because the LLM has all that capability, right? It has all that, you know, environment, right, to do that stuff, right? So I think that we, you know, we need much better ways to attack all this because we need much better ways to defend this, to understand the actual scale of this. And this is where, if I go back to that point of saying that the LLMs are your biggest insider threat, is that in the past, when your APIs got popped, right, you were limited by the functionality of those APIs, right? And even there was other APIs, you kind of were limited by that. In an LLM world, in an agent world, what actually happens, your attack surface is the universe of the tokens that you gave to that agent. And even more interestingly, it's not even added, it's like multiplied. Right? So if you have one agent that can write your email or edit your calendar, it can destroy your calendar. In fact, actually, I forgot one here that I want to add, is also most of our databases don't have integrity protection, right? Most of our databases overwrite the data, are not transactional. What that means, it means that, for example, your calendar, if I go to, or an agent go to your calendar and it creates 10,000 entries, good luck going back, right? Trying to go back to that moment in time. Even at corporate environment, most backups are backups at the point in time. So good luck going to the business going, oh yeah, I can restore it to yesterday's data, but I'm going to lose all the data, right? Since, right? So most of our databases have no integrity protection, they have no transaction support, right? And they overwrite stuff. Now imagine that environment with an LLM raising havoc on top of it, right? Either on purpose or maliciously, right? And again, you can even have ransomware on top of all this stuff, right? Just for good measure, right? So there you go. I think on time, that's the end.